recording, so don't forget. All right, it's week 8, and guess what? Next week is spring break. Yes, we don't have any classes next week. Next week is spring break. You can come and sit in the classroom if you wanted to, but there will be nobody else here. I won't be here. Spring break, not a chance. Now, spring break starts anytime you're done with your work for the week. If you look at this week's assignment and you can finish it up and get all your other classes completed, you can start spring break anytime you want, because it is what it is. Now, I will say that if you're a student that is behind or you have a lot of incompletes, I would use spring break to get caught up, because when we come back, it'll be week 9, and before you know it, we'll be ending the semester. And it goes by fast. I just want to say that spring break is your last chance to, if you're behind, to get caught back up, because once we get going again after spring break, there really isn't a whole lot of breaks in there before the end of the school year. All right, this week we are going to be talking about logarithms and exponents. It's now let's see here. I think we have who is that? Angela, you're finished with this week's work, aren't you? I was surprised to see you in here today, because I think I already corrected your assessment for this week. Pretty easy. All right. Now, it's going to be new for some people, so I mean it'll be okay. We're not going to be doing change of bases this week, so you won't need a calculator this week for what we're working on. Everything you should be able to do in your head. When we come back from spring break, we'll be getting into more intense logarithms and exponential functions. We're going to be solving some this week, but we're going to be solving the really easy ones. When we come back from spring break, we're going to be solving ones that you'll definitely need calculators for. Okay? And Desmos does have a log with a different base other than 10, so you won't need to do change of base formula, but we're not dealing with that this week. Okay, so the first thing that you have to be able to do this week is you have to be able to rewrite an exponent as a logarithm and a logarithm as an exponent. So if I gave you something like, and I think that's how this assessment starts this week, is the first 10 questions just asks you to rewrite a logarithm as a exponent and a exponent as a logarithm. So if I gave you something like the log base 3 of 9 is equal to 2, this is a logarithm. Okay, what is a logarithm? A logarithm is another way of writing an exponent. It is the exact same thing as an exponent. So how would I rewrite this as an exponent? Well, this is your base, so it would be 3 to the second power is equal to 9. That's how you rewrite a logarithm as an exponent. So this is your base. This number here is your exponent. This is what it's equal to. So if I gave you something like 4 to the second is equal to 16, and I said, hey, rewrite that as a logarithm, this is the base of the log. So this would be log base 4 of 16 is equal to 2. That's it. So you have to be able to go from an exponent to a logarithm and a logarithm to an exponent. That's how it works this week. Now, we won't be doing, as I said, we're not going to be doing any of the hard logarithms until after spring break. How should we annotate the log base on our assessments? Now, it all depends. If you're just writing it, you just write it lower. If you're typing it in, I maybe just put a parenthesis there. Maybe just go log and then parenthesis 4 of 16. That way I'll know that that 4 is going to be the subscript. Yeah, that would be fine. I would know that you are meaning that 4 to be down below. Okay, so that's an easy way of doing it if you don't know how to put the subscript in there. All right, so now rewrite each equation in logarithmic form. Now this is way too easy. I mean, and that's how your assessment starts this week. So this is going to be log base 81 of 9 is equal to 1/2. This would be log base 16 of 256 is equal to 2. This would be log base 7 of 49 is equal to 2. And this would be log of 12 of 144 is equal to 2. Done. That's it. So the first part of the assessment is being able to rewrite an exponent as a logarithm and then a logarithm as an exponent. So how would I rewrite this? Well, this would just be x to the y power is equal to 191. Here, this would be 5 to the negative second power is equal to n. This would be 5 to the 19th power is equal to x. And this would be n to the negative 6 is equal to m. So that is how your assessment starts. Pretty straightforward. Okay. 1/5 squared equals n. Now, if I'm not sure which problem you're looking at, but if you had a fraction and you had to write an exponent, I would put the whole fraction inside an x like that. Okay. Oh, if it's a negative exponent, you could. I see what you're saying up here. I would just leave it like this because it's just asking us to rewrite it. It doesn't, we don't have to change it or anything. So you can just leave it just like this. Okay. Yep, don't have to solve it. Not yet. Just rearranging. Now here's some of the rules for properties of logarithms. If you have the log base b of b is equal to 1, what does that mean? That means, like, if you had, and this is where it gets to, do you really understand what's going on? If I gave you log base 3 of 3, that equals 1. Why? Could you tell me, can anybody tell me what this answer would be? Log base 2 of 16. What would that equal? Without using a calculator, 4. That's right. Because what is a logarithm? It's an exponent. When I look at a log like this, I always put like a little exponent there. 2 to what power is 16? Well, 2 to the 4th power is 16. So log base 2 of 16 is equal to 4. That's what it is. That's what a log means. If I gave you the log base 3 of 9, what would that equal? It equal 2. Because log 3 to what power is 9? Well, 3 to the 2nd power is 9. So my answer would be 2 there. So you are going to be asked to find the logs of some numbers without using a calculator. But you should be able to do that. Now, that's why when they give you log base b of b is equal to 1, that really means, like, if I gave you the log of 5 is equal to what? Well, 5 to what power is 5? 5 to the 1st power is. And if you ever get something like this, if you're given the log base 5 of 1, what does that equal? Well, guess what? 5 to the 0 power. Anything to the 0 power is equal to 1. So that would equal 1. Now there's one other rule that I want to give you today that's going to help us. And it's this rule. Log base 2 of, let's say, 16 to the 5th power. Okay? Anytime you have an exponent up here, you can bring that to the front. You can just write that 5 right in front here. Why does that help? Because now, look at this problem. What is the log base 2 of 16? It's 4, isn't it? And then since I have that 5 in front, the whole problem just turns out to be 5 times 4, which is 20. That's not that bad. But if you had to figure this out, the log base 2 of 16 to the 5th, well, guess what? You'd have to take 16 to the 5th power, which is some huge number, and then try to figure out 2 to what power is that? Well, I can tell you what it is. It's going to be 20. That's why being able to move that number out in the front, it really helps out a lot with these types of problems. So those are 3 rules that you really should know this week. There's a nice blank screen there. All right, so that one's gone. All right, evaluate this using mental math. What does that mean? Don't use a calculator. What's my answer here? 3. 5 to the 3rd power is 125. Boom, done. That's using mental math. I believe there's some problems on the assessment like that this week. I'm not 100% sure, but I believe there is. Right here. Uh-oh. Mr. Schenka, now you're making it hard. 5 to what power is equal to 1/5? Oh, you guys are too smart. 5, remember what a negative exponent does. 5 to the negative 1 is 1/5. Yes, that is absolutely correct. Very nice. Now, the last two types of problems are the ones that are the hardest this week. Okay? To solve an exponential equation, if I gave you this, if I said 2 to the third power is equal to 2 to the x, what do you think x would have to be in that problem? 3, right? Because if the bases are the same, the exponents have to be equal. And that's what this says. If you're solving an exponential equation tonight, if the bases are the same, you just set the exponents equal to each other. So in this problem, it would just be 3 minus 2x equals negative x. Then I would solve this. I would add 2x to both sides. This would give me 3 is equal to 1x, x equals 3. Huh, awesome. Okay. This one here, bases are the same. Well, if the bases are the same, then the exponents are equal. So this would be 2a is equal to negative a. Hey, I'm going to add 1a to both sides. If I add 1a to both sides, I end up with 3a equals 0. Divide through by 3. A equals 0. Boom. Okay, here's the hard problem. Are the bases the same? No. However, is 8 equal to 2 to the third power? Yeah. So in place of 8, in place of this 8, I'm going to write it as 2 to the third power. I still have the exponent there, x minus 1, that's still there, is equal to 2 to the x plus 2. Now the bases are the same. And if the bases are the same, then the exponents are equal. So I would just rewrite this as 3 to the x minus 1 is equal to x plus 2. And then I can solve this. So that would be 3x minus 3 is equal to x plus 2. And that would give me 2x equals 5. X equals 5 halves. Woo! So those are the toughest types of problems that you'll get tonight, where you have to be able to make sure the exponents are the same. Here's one problem that most people are gonna not understand. What if I gave you something like this? What if I gave you 3 to the 4x plus 5 is equal to 1? How can you rewrite that with the same bases? How am I going to write 1 with that same base? Why 0? Why can you just say it equals 0? See, on an assessment, I would question that. So basically what you're saying is 3 to the 0 is equal to 1, right? So in place of this 1, I'm going to put 3 to the 0, because that is 1, isn't it? So now I have the bases are the same. So 4x plus 5 is equal to 0, and I can solve that problem. So anytime it's equal to 1, I mean, you could put 3 to the 0, you could put 4 to the 0, you could put 5 to the 0, 6 to the 0. It all depends what the base is. No, because I didn't have to change the left side. The left side was already 3. Okay, it was already 3, so I didn't have to change. I didn't have to change the side. I had to change this side because I didn't have 3 as a base. I needed to have the same bases. Okay. All right. So now the other type of problem you're going to get is solving logarithmic equations, one-to-one property. Now these are the easiest. If you have a logarithm on one side and a logarithm on the other side, you can just cross them off. Okay. What I just said 3, because anything raised to the 0 power is 1. So I just said, hey, 3 to the 0 is equal to 1. So now I have same bases, right? So I would have written 1 as 3 to the 0. because that gives me a base of 3. Anything raised to the 0 power is 1, right? That's one of those rules that we learned with exponents. Okay, so now the one-to-one property for logarithm says if you have one log on one side, one log on the other side, and they're to the same bases, okay, they have to be to the same base. If they're not to the same base, you can't do it. So if I gave you a problem like log base 3 of x plus 4 is equal to log base 5 of x squared minus 2. You can't cross these two logs out. You can't. They're not to the same base. So it doesn't work. But if the bases are the same, now how do you know the bases are the same in this problem? Well, if the base isn't written in, it is assumed to be 10, right? So I could write the 10 in there if I wanted to. 10, 10. So now I have one log on one side, one log on the other side. They're both to the base 10. So guess what? Boom, cross it out. 5x equals 2x plus 9. Solve it, you're done. Okay, same thing with this. Let's say I put 3 in here. Let's say it was log base 3, log base 3. Well, the logs are the same. Cross them off. Boom, boom. I've got 10 minus 4x equals 10 minus 3x. And then I would go about solving the equation. Okay, now, I'm a little slow here. I don't have my decimals up. Sorry about that, guys. I want to make sure we get through these problems. So that's pre-college. That's not what I wanted. Algebra 2. There we go. Algebra 2, week number 8 is what I'm looking for. Semester 2. Uh-oh. Huh. All right. Oh, here we go. There we go. Okay. Logarithms. Oh, that is definitely not what we're looking for. Okay, that is definitely not what we are looking for here. Let's try that one. Okay, so, okay, that looks a little bit better. All right. So let me give you guys the, oops, nope, that's not what I wanted to do. Ugh, I'm out of it today. All right, so here is, nope, right, darn it. Let's try this again. Okay, here is the Desmos presentation for today. After much to do. There we go. All right. So let me share my screen with you guys. Boy, this is really not working the way it's supposed to work. What the heck is going on here? All right. Okay, there we go. My computer is really acting up this morning. All right, Algebra 2, Algebra 2, Algebra 2. There we go. All right, so here we go. Do you guys see the first problem? It says write the equation in logarithmic form. All right. Fairly easy problem, right? You guys are saying the answer is A. Remember, if you're writing a logarithmic form, this is, so it's just going to end up being log base 6 of 1,296 is equal to 4. Boom, done. So letter A is correct. All right, fairly easy problem. Now, there's a lot of easy problems on this week's assessment, or practice. The assessment's not bad either. Evaluate the logarithm. So they want you to evaluate this thing. It means without a calculator. I don't want you guys using calculators this week. So what is the log base 5 of 1 over 625? -4? You guys agree? It definitely has to be negative, right? Okay. Because, and this is, when I look at a problem like this, now you could put an X out here, and then you could just go, oh, 5 to what power is equal to 1 over 625? Well, you could put positive numbers in here all you want. I mean, 5 to the first is 5. 5 to the second is 25. 5 to the third is 125. 5 to the fourth is 625. but that doesn't ever get me to 1 over. But what if I put a negative here? Oops. 5 to the negative first is 1 over 5. 5 to the negative second is 1 over 25. 5 to the negative third is 1 over 125. 5 to the negative fourth is 1 over 625. That's what a negative exponent does. It just puts a 1 on top, right? So that is how I would come up with that answer. So the answer is -4. It is correct. All right. Number 3, we have write the equation log base 32 of 8 is equal to 3/5 in exponential form. Okay. And obviously you guys don't have to write it down. You can just tell me which letter it is. Letter A. Okay. Good. Because if I had to rewrite a logarithm as an exponent, it's the base. So that gives me 32 to the 3/5 power is equal to 8. That is correct. Number 4, we have a 27 express 27 to the 1/3 equals 3 in logarithmic form. So now I'm rewriting in logarithmic form. We're seeing that the answer is letter C. There's a lot of C's in there. And that is correct. Because remember, if I'm taking an exponent and writing as a logarithm, this is my base. So this would be log base 27 of 3 is equal to 1/3. And that would be the correct answer. Number 5, it says solve. All right, so this one, it says solve, which, I mean, I don't know. You won't have any of these types of equations on there, but, you know, the first thing I would do is I'd look at it and say, okay, I'm going to rewrite it as an exponent. So that would be x to the 4th is equal to 81. So what to the 4th power is equal to 81? And the answer should be 3, right? 3 times 3 is 9, times 3 is 27, times 3 is 81. So that would be 3 to the 4th power is equal to 81. So the base would be 3. Very good. Just a real quick, you know, as I said, we're not getting into anything real deep yet. When we come back from spring break, we get into more of the harder type of logarithm problems to solve. And I really enjoy them. But you do need to know the basics. You have to be able to rewrite an exponent as a logarithm and a logarithm as an exponent in order to solve the harder ones. And that's why we're going over them this week. Didn't want to get into anything real difficult right before spring break. All right. In this problem, it says evaluate log base m to the 2n. All right. This one would make really a lot of sense to take that exponent to the front. Yeah. If I can take that exponent to the front, then, and remember that rule, we can bring the exponent to the front. Whoops, not the front of the evaluate, to the front of the log. So I'm going to rewrite that as 2n log base m of m. Well, this is pretty easy. What does that equal? What does a log base m of m equal to? And that is 1, right? So this is 1. So now I have 2n times 1, which is just 2n, which is letter D. Pretty awesome. The rules really help a lot. So, you know, once you understand the rules, it's pretty easy. Number 7. All right, I am going to let you guys do this problem because I haven't taken attendance yet. I apologize. I'm sorry. Let you guys do this problem. I'm going to take attendance real quick, just so I have it. Let's see here. And most of you probably have the answer before I'm even done taking attendance there. Let's see here. I missed one student there. All right, so the answer is, let's go back to there. Because 2 to the second is 4, so 5 times 2 is 10. So the answer is 10. So that's some pretty good explaining. In this problem, I have an exponent, 5, so I'm going to write that right in front. So this is 5 log base 2 of 4. Now this I can do in my head. 2 to what power is equal to 4? Well, that's 2. So this whole thing is 2. So I still have that 5 out in front. So 5 times 2 is 10. So 10 is the correct answer. All right. As I said, I think you guys are going to have an easy time this week with the assessment. All right, number 8. It says to evaluate. Ugh. Now, this one, I would want you to evaluate it without using a calculator. So what I'm going to do, I'm going to show you how I would do this problem. How can you rewrite the third root of 64 as an exponent? Does anybody remember how to do that? How do you rewrite an x? How do you rewrite the third root of 64 as an exponent? That's why we get rid of them, Samantha. If you don't like exponents, rewrite as an, if you don't like radicals, rewrite as an exponent. What is the third root of 64 as an exponent? And that is not bad. So I remember from way back when that a radical is a power to a root. That's what it is. So I can rewrite this as 64 to the 1/3 power. That is how I would rewrite it. Okay. Now, why would I do that? Because now my next step, I would just rewrite this as the log base 2 of 64 to the 1/3. I'm going to write that. I'm going to put that out in front because I don't want that exponent there. So 1/3 log base 2 of 64. This I should be able to do in my head. Okay, 2 to what power is 64? The fourth? I don't think so. I don't think 2 times 2 times 2 times 2 is equal to 64. 2 to the 5th power. 2 to the 8th power. Are you guys just guessing? 2 to the 6th power. 2 to the 6th power is 64. Okay? You guys had everything around there. So 2 to the 6th power, because 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So 2 to the 6th power. So this right here, this whole thing is equal to 6. So now my whole problem just turns out to be 1/3 times 6, which is 2. That's how I would have done this problem. Now, some people would have done it different. So for example, let me see if this works. 4 times 4 times 4. Okay. So the third root of 64 is 4. So you could have just rewritten this whole problem as the log base 2 of 4. Because the third root of 64 is 4. And then what is the log base 2 of 4? It's 2. So it's the exact same answer. So I saw somebody write that up in the chat. I know, Angela, you did. So it could have been made a whole lot easier if you just notice that the third root of 64 is 4. But I would have done it the other way. I would have rewritten it as an exponent and done it that way. But because I didn't see that. I didn't see that the third root of 64 is 4. So it's like, all right. But they both give us the same answer. We still got 2. All right. Number 9. We have, so this is, okay, this is a good problem. I am going to let you guys work on this problem because this is, when you get down to problem number 3 and 4, number 3 is solving, I believe, exponential equations just like this. And number 4 is solving logarithmic equations. Okay, so what I'd like you guys to do is try this one, see what you get for an answer, and then we'll work through it. Okay, we have a couple answers of C. How do you even do this? It's a good problem. All right, so when we're trying to solve an exponential problem, we want to write it with common bases, right? If the bases are the same, we set the exponent equal to each other. Okay, say that 100 times in your head, because that's how you solve an exponential problem. You've got to get the bases to be the same. So if the bases are the same, then you set the exponents equal to each other. Now I see a couple people right away saying 5 to the negative third power is the same thing as 1 over 25. That is the key to this problem. I've got to rewrite this with a base 5. So 1 over 125 is the exact same thing as 5 to the negative third power. If you knew that, this is a pretty easy problem, because now the left-hand side didn't change. It's still 5 to the 2 minus x is equal to 5 to the negative third. I just rewrote the problem so the bases are the same. The bases are the same. So if the bases are the same, you set the exponents equal to each other. And you solve, and that's your answer. So I'm going to subtract 2 from both sides. So negative x equals negative 5. So x equals positive 5. That wasn't that bad, but I did have to get the bases to be equal. If you did not get the bases to be equal, you can't solve the problem. Okay? So does that make sense? That and this was a tough one, because a lot of kids, they don't understand 1 over 25 is the same thing as 5 to the negative third. And that's where the trick comes in. It's like, oh, Mr. Shanklin's trying to trick us on these things. Okay? So now what if I did this problem? Okay? So I'm going to change the problem just a little bit. And so this is not the same problem. What if I gave you this problem? 5 to the 2 minus x equals 1. Okay? What if that was the problem? How do you make the 1 to have a base 5? Because I need it to be base 5, right? Because that's what the left-hand side is. 5 to the 0. That's exactly right. That's when you can rewrite this. 1 is the same thing as 5 to the 0 power. So in place of this, I would put 5 to the 0, because now I have the same bases. So if I have the same bases, I can rewrite it as the exponents are equal. So I know some people had a question on that problem that we did before we started doing the practice problems, and they were wondering, how did I change the 1 to have a different base? Well, anything to the 0 power is equal to 1. So that's why in this problem I would just rewrite it as 5 to the 0. Okay, does that make sense? Okay, because that one, there's a problem like that on the assessment, and a lot of kids they'll wonder, how did you get the same base there? Oh, okay. All right, here's the last problem. It says evaluate log base 10 of 1 over 1,000. Okay. Letter D, negative 3. So 10 to the negative third power. So you're saying 10 to the negative third power is 1 over, so 10 to negative third power. Well, 10 to the negative 1 is 1 over 10. 10 to the negative second is 1 over 100. 10 to the negative third is 1 over 1,000. So yes, log base 10 of 1 over 1,000 is equal to negative 3. That is absolutely correct. And you shouldn't have to use a calculator for that. You should be able to do that in your head. Whew. That is it, ladies and gentlemen. Next week at this time, what will you guys be doing? Some of you hopefully will be sleeping. Nothing, schoolwork. And remember, classes never close. So, if you are behind, next week will be a great week to catch up. So we never close our school. You can always work. However, you can email your teachers and all that, and you might not get an email back, but you'll be playing video games. Awesome. All right, that is it for this week. I hope, if you guys need some extra help, we do have a help session on Wednesday. I was amazed. Last Wednesday, nobody showed up for the help session. I was like, oh no, nobody. And it's like, oh yeah, nobody. I get to go do stuff. And this week on Wednesday, it's supposed to be 62 degrees. Whoop whoop. Love it. All right, you guys have a great one. Bye.